Question 2, consider the function below f of x equals the absolute value of 3x plus 3, g of x equals negative x squared plus 8x minus 5. Represent the interval where both functions are increasing on the number line provided. So I'm going to use I really need a visual to help me answer this one first. But before I get to that point, let's think about, okay, f of x. We've got an absolute value graph. So this is going to be a V-shaped graph. It's going to be shifted up 3, and it may be horizontally compressed just a little bit. But basically V-shaped graph. G of x is a quadratic, I know, because of the x squared term here. There's a negative in front of the x squared, so this tells me this is an upside down u. So the reason I want to get that visual, that initial visual, is when we're talking about where these functions are increasing, it's where the functions are going up from left to right. So for instance, this quadratic, this parabola, this is where this graph is increasing. It's increasing here from negative infinity all the way to this tip-top point. The V-shaped graph is increasing from left to right, starting at this bottom point, and as we move up and to the right there. So that kind of gives us an idea, but let's get a more specific look at these graphs by going to a graphing calculator. You can use Desmos, you can find a TI-84 online for free, or even an app on your phone, and we're going to graph these. So to graph the first function, you need to find the absolute value symbols. So in this calculator, you have to press the math button, scroll to the right to NUM, and choose number 1 for abs. And we're going to type in 3. X button is here next to the green alpha key. Plus 3. Let's just go ahead and graph it, see what it looks like. Yeah, we can see where it's increasing. Let's go back to y equals, go scroll down to y2, and we're going to type in negative x squared plus 8x minus 5. So now we get a better look, because the question wants to know where both functions are increasing at the same time. Well, it appears from the bottom point of the V-shaped graph to the vertex of the parabola, that's the only space where both of these graphs are increasing. In other words, I drew a little makeshift graph. This is what we're dealing with, but really the correct answer is only in this range right here. And specifically, when we write the interval where a function is increasing, we only use the x values. So what x value does the increasing begin at? Well, it begins right here where it's happening for both graphs, right at the vertex of this V-shaped graph, which we can tell the x value for that point is just 0. So beginning just after 0, it begins to increase. So we're going to put our first open dot at 0. We can't include 0 because that would define that we're increasing to get to 0. And we're not really doing that. We're starting at 0 and increasing from there. The x value that we're stopping the increase is at this highest point of the parabola, the vertex. And to find the x coordinate of the vertex, recall the formula is x equals negative b divided by 2a. So let's take the quadratic in this problem, which was negative x squared plus 8x minus 5. And let's review. The a value is the coefficient in front of the x squared term, which is negative 1. The b value is the coefficient in front of the x term, which is 8. C value, which we don't really need, but it's the constant, it's negative 5. These are the two values we need to substitute in this formula because this gives us the x coordinate of the vertex, which is where the increasing stops for these problems. So x equals negative 8 divided by 2 times negative 1. That's negative 8 divided by negative 2, which equals positive 4. So it stops increasing at positive 4. So that's our answer.